Hello everyone, this is Preeti Verma from Computer Application Department. Today I am going to discuss about convolution neural network. So far we have seen artificial intelligence is trying to bridging up between the machine capabilities and human. Researchers and enthusiasts are working hard to get the things happen. So one of that many applications, one is computer vision. So in computer vision, what artificial intelligence is trying to do is it wants to enable the machine to view the world as human do. So with the help of deep learning and computer vision, you can get these things done. So in image processing, we can see there are lots of applications. So self-driving cars, face recognition, image classification, object detections, these are the various areas where computer vision is working. You can see that in first image, cat image is there. So with the neural network or with the convolution neural network, we can get the classification that whether this picture is of cat or some other animal. Or in the second picture we can see object detection, like in self-driving car will be having the cameras, so there we want to detect the objects. So these kind of problems can be solved from the convolution neural network. So the problem with image processing is the image size will be the greater. So here we can see one picture that has the pixel value of 64 x 64 x 3, that is 12288. With the neural network there will be not a problem, but if the other picture that is having 1000 x 1000 into 3, that is 3 million pixels, that will be the input value to the neural network. That will be very huge, and this will become the neural network very complex. So how we can solve this problem? With the convolution neural network we can solve this problem. So in convolution neural network we will give the image as the input. Now what is image? Computer sees an image as an array of pixels. You can see like so many of images that has the pixel values. So the image will be the pixel value, that is the matrix of the pixel values. So here is the whole architecture of convolution neural network. There you have given one picture of the car, okay, that is nothing but the matrix of the pixels. Now the convolution layer is applied onto the picture, then nonlinear function is applied to the picture, and then pooling layer, then again convolution layer, then again pooling layer. This whole process is convolution neural network. After getting the reduced size of the image, we will give it to the neural network for the prediction. So how this convolution pooling layers are working, we will discuss here. So what is convolution? Convolution is trying to get the feature from the image. So it will reduce the size of the image while keeping the relationship between the pixels. So here you can see I have one image that is 5 x 5 images this, and one filter is there that is 3 x 3 filter. So this filter is convolving around all over the picture to get the features and to reduce size. So you can see the image size is 5 x 5, the output size is 3 x 3. We can use more than 2 filters or 300 filters or 1000 filters to get the features from the image. So here you can see the red one is the one filter and the blue one is the second filter. The input image is the same, and with the first filter you will do convolution, and with the second filter you will do the convolution, and you will get the output which will be having the 2 channels. So that things we have to remember, that how many filters you are working on the image, that will be the number of output channels. Now what is filter? Filter is trying to extract the features from the image. Like if you want to extract horizontal edge, vertical edge or tiger stripe from the image, so you can use so many of filters that will extract the information without changing the image, but reducing the size of the image. So these are the some filters example that we can use in the convolution. Like for sharpening the image, there is one filter. For blurring the image, there is one filter. There are so many thousands of filters are available online. We can use that filters to get the information from the image. Now we'll see how the convolution process is working onto the 2D image. So we will take the simple example, that is single filter to a 2D image. So we will have the one image and the one filter. How we will compute this is just the multiplication and addition function. So what is the value of the filter and the corresponding pixel value into the input image, you have to multiply and you have to add all the values. So here you can see into the picture, here this is 7 cross 7 matrix is there and the filter size is 3 cross 3. So this filter is convolving around the image. So first 9 pixels it is convolving and we are getting only 1 pixel as the output. So it is reducing the size of the image. So as general rule we can use, if the input image size is n cross n and the filter size is f cross f, then the output size will be n minus f plus 1. The other case is you can use multiple filter in one single input image. Okay, so here you can see in the figure, black is the input picture. Okay, then we are using 4 different filters, that is red, yellow, blue and purple. So every filter will convolve all over the image and you will get one 2D image. Then again second filter will convolve over the full input image, then again we'll get second 2D image. And we have seen previously the number of channels in the image is equal to the number of filters. So here one input image is there and 4 filters we are using, so the output will be the 4 channels with the 2D image. Now how this convolution process will be done in 3D image. So here also the same formula is number of channels in the filter should be equal to the number of channels into the input image. So here in the picture we have one 3D image that will have the green, blue and red dimension. Then we will be having the filter with the same number of channels. Here it is 3. It is 3D image, means it is having 3 channels. So filter will be also having the 3 channels and every channel will be multiplying and adding with the corresponding channel. So after applying the one filter in one 3D image, we will get the output one 2D image. So because we have applied only one filter. Here we can see multiple filter with multiple convolution. So here one image is having the 7 channels. So your filter should also have the 7 channels. Now you are using multiple filters. So as many as filter you can use, but it should have the 7 channels. Then every filter will convolve with the input image and it will produce the one 2D image. So here we have used 4 filters. So the output channel of the image will be 4. So again you can see here, again I have taken one 3D image. Again we have taken one 3D image and 2 filters I am using. So the 3D image input size is 6 cross 6 cross 3. So the filter what we have taken, it is also having the same number of channels as the input. Input has 3 channels. Input has this 3 channels. So filter is also having here 3 channels. So after applying the first filter to this image, what will be the output size, that we'll discuss later. Now padding is the word is using in convolution neural network. There is one problem in convolution neural network, that is in corner pixels value we are not taking that much as compared to the center pixels. So there can be a information loss. So what is the solution? Solution is padding. What is padding? Padding is we will add few values or some values to the border of the images. That is called padding, and if that value is 0, then it is called zero padding. So here you can see in the picture the gray values are the padding values. Now if you will convolve the filter to the image, then it will take as much as center pixel it is taking, it will take the as much as corner pixels also. So how padding is working, here you can see the first 3 cross 3 pixels we have taken. So this is the image with 3 channels, and the filters also we are using 3 channels. Okay, so what will be the output size after padding? So if our input image has n cross n size and padding is p and filter size is f cross f, then the output image will be the n plus 2p minus f plus 1. We'll see one example. Let's see, the input image size is 6 cross 6 and we are using the filter 3 cross 3 and padding is using 1. So what will be the output image size will be 6 plus 2 minus 3 plus 1 equal to 6. So here you can see the output size is equal to the input size. Here this is the use of the padding. There are 2 types of padding, that is valid and same. In valid padding, if there is no padding you have given, that is called valid padding, and the output image will be the similar like n minus f plus 1. Same padding is that the output size is the same as the input size. If you are using the number of paddings you are using, that will give you the result as the same as like the input size. The second term we are using in the convolution neural network is stride convolution. So when we are convolving the filter into the input image, then we will shift the filter to the right or bottom with the 1 pixel or 2 pixel or 3 pixel. That is called the stride length. So if you are moving the filter to the 1 pixel, that is stride length equal to 1. If 2 pixel, then stride length will be the 2. Now what is the use of the stride length? Why we are using this stride convolution? This will reduce the image size faster ways. So in the picture you can see, in the first picture we are taking the input image 3 cross 3 means 3 cross 3 pixels of the input image. So here our input image is 5 cross 9 size. Okay, and our filter size is 3 cross 3. So starting 3 cross 3 pixels we are going to take from the input image and we are doing the convolution. Next, when we will slide our filter, we have slide 3 pixels, means here we have taken stride length equal to 3 for the horizontal sliding. For vertical sliding, here we have taken the 2 stride length. So what will be the output image size after using this stride? So if the input is n cross n image and the filter size is f cross f and the padding we have used p, what is the value of p? If p value is 0, means we have not used the padding. If p equal to 1, means only one border we have taken, one border is only used for padding. If p equal to 2, is that 2 borders we have used for padding. Then what will be the output size of the image will be n plus 2p minus f divided by s plus 1. So this is the simple example. Here you can see the input image size is 39 cross 39 cross 3. So the number of channels here is 3 and the size is 39 cross 39. Now we are using the filter size is 3 cross 3. Stride length we have taken 1 and no padding we are using, and we are using 10 filters. So the output 1 will be how this 37 has came. You just have to put the values in the formula n minus f plus 1. That is n is 39, f is 3 plus 1, that is 37, and the number of channels will be the equal to the number of filters. So here we have used 10 filters, so here number of channels will be also 10. Again we are going to use the one filter, that is the size of 5 cross 5, and we are using the stride length of 2, and padding again it is 0, and we are going to use 20 filters. So again the output will be 17 cross 17 into 20. 20 is the number of filters what we have used. Similarly, when we will get the output like 1980, that can be handled with the neural network. So these pixels we can send to the neural network for the prediction. We can use the pooling layer also in convolution neural network. Why this pooling layer is used? It will also reduce the size of the image by extracting the dominant feature without changing the image. So here you can see one picture of the bird is there. We have just used the pooling layer and we have reduced the size of the image. So here you can see the example, like we have the input image of 4 cross 6. This is 4 cross 6 input image is this. So we are using here, this is pooling layer. So you are taking the dominant feature from these 4 pixels. So from these 4 pixels, 1 pixel will come into the output. Here also with these 4 pixels, 1 pixel will come into the output. So to full all the image, we will do the pooling layer and we will get this 2 cross 3 image of pooling. So pooling can be the two types, that is first is max pooling. In max pooling what we will do, this is our input image, 4 cross 4 images there, and we have taken stride length equal to 2. So here 1329 will be the 4 pixel, and from 4 pixel we will take the maximum value of the pixel, that is 9. So here you can see 1329, we have taken the output pixel as 9. Here again 2111, with these 4 pixels we will take the maximum value from that is 2. So this is called max pooling. The another way of pooling is like average pooling. In average pooling we will do the average of the pixels. So here 1329 we will do the average of these pixels. So we will add all these pixel value and divide by 4, which comes into 3.75. So this is average pooling. Now again we'll see the simple convolution neural network example with the convolution layer and the pooling layer. So in the convolution neural network you can use as much as convolution layer and pooling layer. You have to decide how much convolution layer and pooling layers you have to use, and the sequence also we have to decide. After how many convolution layer we have to use the pooling layer and how many pooling layer we have to use. So here you can see we have one input with the 32 cross 32 cross 3 channels, and here we have used the filter and we are using the convolution layer. Then again we are using the pooling layer, then again we are using the convolution layer, then again pooling layer. So this all process has been done for reducing the size of the image, but taking the relationship between the pixels should not be changed, but to reduce the size. So this is another example. This is the one picture of the vehicle. So we have to predict this vehicle is the car, truck, or is the bicycle or ship. What vehicle is this? So we will use the layers of the convolution and pooling layers, and then we will predict from the convolution neural network what is this vehicle. So you can use the convolution layer, then ReLU is the one non-linear function that you can use. There are so many non-linear functions, sigmoid function, tanh function. You can use any non-linear function. Then again we have used convolution layer, then again we have used non-linear function. So this combination will give you the output as the what is the image, this. So we have seen this much about convolution neural network. This is the simple representation of convolution neural network. In the next lectures we can go further with some examples of convolution neural network.